So, welcome. So if you haven't met me before, I'm a data visualization specialist. I mainly use a combination of R, Python, and more recently D3. But my background is in statistics and operational research and data science. And I have built quite a few R packages. Quite a few are public, and there are lots more private R packages as well. Most of the packages I've built have been for visualization. Okay. So what we're going to do during this workshop is build an R package. Okay. It's going to be a combination of some slides. We'll do some live coding examples, and there will be some exercises for you to participate in. Okay. Please do ask questions throughout. Okay. I will try to answer any urgent questions as we're going through, but I'll also pick through the questions as you're doing the exercises. I'll go through those. Okay. If you do want to code along, please do. You can code along as I'm live coding, or you can wait for the exercises, or you can kind of just sit back and listen if you'd prefer. Okay. Okay, so there's a link on screen now to these slides. I will update the slides after the session with links to all of the code that goes through the examples as well. So if you want to look back on it afterwards, you can. Okay. Okay, so I can see there's in the chat, it doesn't look like I can send messages to anyone other than the hosts and Phil.
Okay. Let
Um,
me see if I can change that. Sorry about that.
I think Mike has just put a link on there as well. So the sort of second last message, there should be a link to the slides there from Mike. Um, but otherwise, you can type it out if you absolutely have to.
Maybe try now and see if you see everyone.
Yes, I can.
Okay. Sorry about that.
Perfect, thank you. Right. So that should take you to a web page, and there'll be a link to the slides there. Okay. Yes, you can download the slides if you want. You can get them as a PDF copy. You can go PDF export mode, and then you can go file print if you want to download them. You should also be able to right click and go save as, but I don't know if that'll download all of the styling. Something might look quite ugly if you try to download the HTML version. Okay. So in terms of the workshop today, um, you're going to need, if you want to code along, you're going to need access to an R environment. Um, what we're going to be using is Posit Workbench, okay? And I'm hoping Phil will ping a link to that in the chat. Um, you can also use your own installation of RStudio if you really want to, or you can use Positron if, again, your own installation of that if you want to. I'm going to be doing all of the demos in RStudio. So if you're not too familiar with anything else, I'd suggest sticking with RStudio and sort of following along. We're also going to be using a few different packages. Okay, if you're using Workbench, everything you need is sort of pre-installed. If you're using your own installation of RStudio, you'll need to install at least 3 packages. Okay, they use this package, the DevTools package, and that should be Roxygen 2 package. Okay. Optionally, we will also be installing string R for some examples. But if you have your own code that you want to be working with, you don't need to. Okay. So in terms of prerequisites for this workshop, I'm hoping that you know a little bit of R. Okay, you don't need to be an expert in R. And hopefully you know what our projects are. Okay, if you don't, we will have a little brief recap of what projects are before it becomes important. And you might have written a function or two before, right? Again, if you haven't written a function at all, that's absolutely fine. We will have a little recap of functions, and I will give you some functions to borrow if you don't have one of your own that you want to use. Okay. So In terms of getting started, let's talk about what we actually mean by R packages first. Okay. So R packages are basically a collection of some of the following things. Okay. It might be some functions, it might be some R objects, including things like data sets. Okay. They might also have documentation. Okay. So some nice examples of how you use those functions or that data. They might also have some tests. They might have R Markdown documents or Quarto documents. Basically, anything R related, you can probably put in a package in some way. Okay? You don't have to have all of those things. In fact, essentially, you don't actually have to have any of those things. Okay? The key thing is that they're going to be arranged in a specific structure, and there's going to be some specific files that we need alongside these things. So, I mean, you're all here, so I'm hoping that you want to make an R package, and maybe you understand why you want to make an R package. But if you bundle up your code into a package, it makes it easier to run code, right? If it's sort of nicely formatted, if it's got good examples, if it's sort of well written, it's going to be easier to just run your code. It's also going to be easier to reuse code across different projects. Okay? So in the same way that if you're rerunning the same little chunk of code over and over again, we tell you to, probably put it in a function. If you find yourself reusing the same functions over and over again across different projects, it's usually a sign that you want to build a package and keep them all in there. It also makes it easier to share code with other people. Okay. Particularly people who are maybe less experienced with code or less experienced with the type of code you've written. Okay. If you share an R package, they can use a function without having to look at all of the code that sits behind that function. Okay. Packages also make it easier to read documentation. Okay. So when you're using packages in R, okay, hopefully at some point you've had to have a little look at the help file, okay, um, and seen some nice examples and some descriptions of what's going on. It also helps you to manage dependencies and different versions, um, both of the code and of other packages that you might be using. Okay, so there's lots of different sort of good reasons why you might want to make a package. The other reasons are like it's fun and you just kind of want to, um, and why not? But at the same time, if you've never built an R package before, it sort of sounds like it's for someone who's like really advanced at writing R code. Like it's a sort of a big project to take on. Or it's only for people who have like lots of functions that they need to bundle together, or it's only for people who make functions that do useful stuff, or for code that's ready to be shared with other people, or particularly that you want or need to share it with other people. It might sound like it's a really complicated thing. Particularly, I think if you go on something like GitHub and you look at the source code for some of the, your favorite packages, some of the tidyverse packages, they look really, really complicated, and that might feel a little bit scary to build your first R package. Okay. But these are all myths. Okay. I'm hoping that actually we should have built an R package together within the next like 10 minutes. Okay, a very basic R package. Um, it doesn't have to have any functions. It can have one function, it can have 20 functions. Okay. And it can be functions that do like really trivial things, stuff that's only useful to you, and that's fine. Okay. I've got quite a few R packages that are very, very trivial, and just make stuff that makes my life easier. Okay. It doesn't need to be useful to anybody else. Okay? So I talked about the fact that we're going to have some different files and they're going to be arranged sort of in a specific structure. Okay. So I tend to think of an R package as being a little bit like a recipe, right? So one of the things that we have in every R package is a description file. Okay. So this contains all of your sort of metadata. Okay. So things like the name of the package, who made it, um, the sort of license file, who else can use it, for example. Okay. Then we have an R folder. Okay, and our R folder is going to be filled with our scripts. Okay, so these are all of the things that we want to put into the package. Okay, so all of the sort of ingredients, all the functions that other people are going to want to use. Then we have another folder, okay, uh, called man, and that is all of the essentially instructions for using those functions. Okay, so what do the different functions do? How do we use them? Okay, and what you'll notice is that it sort of pairs up. Okay, so if there's a function in your R folder, there's going to be a matching uh, sort of file for documentation. Okay. The other element of an R package that we always have in every package is something called a namespace. Okay, so a namespace is essentially a bit of like a combination between a shopping list and a menu. Okay, so it tells you about imports and exports. Okay, so what things do you need to go and borrow from other R packages? But also, what things are you exporting? Okay, so what other things are available for other people to choose? Okay. And then you can put a whole load of other stuff in there if you want to. Okay. None of the other stuff is essential. Okay. They're just some nice decorative elements that might make it a slightly nicer looking recipe. Okay. So you can put other things in packages. We'll touch on them at the end of today's session, but we're going to focus mostly on those key elements. Okay. And you might be looking at that list of different files and thinking, this is why I thought that making an R package was complicated, because that's a big long list of files that you have to make, and then you have to like populate them and make sure they're sort of named and structured correctly. And that is how you used to have to do things sort of in the olden days of making R packages. You did have to write all of that by hand. We don't have to do that anymore. Okay. So the use this is like one of the most useful R packages that exists. So it automates lots of tasks, um, not just for R package development, but also sort of non-package projects. It sort of does all that setup stuff, that sort of stuff that's a little bit tricky, but repetitive. Okay. So I promised a quick recap of projects before we get started with some examples. Okay. So if you haven't used projects before, I highly recommend that you use R projects. They're basically a nice way to keep all of your sort of R code, data, and settings for a particular project organized in one place. Okay. And although you don't have to develop a package as a project, we are going to. Okay. One important thing to remember is that we don't really want to nest projects inside one another. Okay, so when we start, we're going to start making a project. So we don't want to already be in a project. The other thing I want to mention that you may or may not have seen before is something called namespacing. Okay? So we don't really want to be using library package name today for a couple of reasons. First of all, it's a really easy way to get your package confused. And second of all, we're going to be, when we're developing, restarting our R session quite a few times, and we don't want it to have to be typing out library package name over and over again. So what you'll see is a way of using functions from packages called namespacing. Okay, so that's where you do the name of the package, a double colon, and then the function name. Okay, so rather than doing library and then just function, you'll see package, double colon, function. Okay. All right, so we are going to do a live demo. Okay, so I'm hoping there's a link in the chat to Posit Workbench, and we're going to open up an instance of RStudio. Okay. Okay. So if there's not a link here,
Oh,
so I'm hoping you can all see that link in the chat. Okay, it should open up something like this. You will need to make an account to log in. Okay. And then it should bring you to a screen that looks like that. So I'm just going to give you a couple of seconds. okay? And you want to be clicking Posit Workbench, okay? Making an account and then clicking this new session button at the top, okay? So again, I'll give you a couple of seconds to log in or make an account if you haven't made one before, okay? If you have any problems logging in, do put a message in the chat, okay? And if a couple of people can just post in the chat when you're ready to go with some demos, um, then we can get started.
Just wanted to mention I put the steps in the chat box. If anyone has any questions, definitely just let us know in the chat, and we're happy to help. There's a couple different ways to log in. You can register, and you can also sign in with GitHub or Posit Cloud. If you've done another R and Pharma workshop, you might be able to just log in with Posit Cloud. I would definitely say the quickest and easiest way is just to register and fill out the information, and then the environment will spin up. And someone says, should we create a new session? We're going to walk you through that part once everybody has logged in and created an account and show you how to get started. But I believe for today, most of what we're going to do is inside a Posit Workbench. So that's where we'll be operating for the workshop today. So I think it looks like for the most part, people are fairly successful. So maybe if you just want to walk them through how to spawn a session there in Posit Workbench, I think we should be good to go.
Yeah, good. Okay, so it looks like most people are getting logged in and no one's having any problems. So that's good. So you want to be clicking on Posit Workbench, okay, and then it's going to open up a window that looks a little bit like this. So what you want to do is click this New Session button at the top, okay. Just leave all of the defaults there and click Launch, okay. And when you click Launch, it will open up a new session for you. Okay, it might take a few seconds. I think it's currently taking about 10 seconds to open up um, the RStudio session. Okay, but it should open up something that looks very familiar in that RStudio session. Okay, so it should um, look very similar to what you work with if you're working with RStudio locally. Okay. So someone's asked in the chat if their default was Positron Pro. Um, yeah, if you've never used Positron before, oh, looks like Positron was default for a lot of people. If you've never used Positron before, I mean, go check it out, but probably not right this very second. So yeah, if you open up RStudio, as your new session, okay, so you can click fourth one along RStudio Pro, and then click Launch.
And if you did spin up a positron environment, you can just hit the back button and go back to the Workbench homepage and then just launch a new session and then pick RStudio, and that should work.
Okay. Um, So I think we're ready to start looking at some demos. Okay. So the first thing to do um, in um, your R Studio is to double check that you're not in a project. Okay, so we're going to be making a project file. So we don't want to already be in a project and end up with lots of things nested. Okay, so what you'll see in the top right, what you should see is project and then none. Okay, that's exactly what you want to see. Okay. If you are in a project for whatever reason, or if you are, if you've accidentally created or you're using your own machine, there's will be a button that's highlighted that says close project. Close that out, um, and make sure that you're not in a project, right? So then what we're going to do is we're going to make an R package. Okay, so the way we're going to do that is we're going to use the use this package. Okay, so again, I'm going to use name spacing. Okay, can everyone see this? Okay, tell me in the chat if you want the text size to be bigger, and we can do that. Okay, so what we're going to do is we're going to do use this, okay, and then create package. Okay, and what we want to do is give our package a name. Okay. And I think it's really unfortunate that choosing a package name is like the first step. because I think it's one of the hardest parts. You can change package names at a later date. You're not sort of committed to it forever. Okay. But I'm going to stick with my cookbook metaphor from earlier. Okay. And call it cookbook. Okay. So use this package, double colon, create package, and then in quotation marks, the name you want to give your R package. Okay. And then we hit enter. Okay. And you'll see that it's doing a bunch of stuff. And you get a sort of open session message. Sometimes it does it automatically, but it might need you to click a button. Okay. And it should start opening a new session. Okay. And so now when you open up, you should essentially be opened up a new um, R Studio session, okay? But you should notice a couple of differences, okay? So first of all, if you go up to this project bit at the top, okay, you're now no longer not in a project. You should be in a project with the same name as you gave to the R package, okay? And you should also see a whole bunch of files in your folder, okay? You might see some git ignore or build ignore files. I would ignore them for a second. You'll see that our project file. Okay. You'll see the description and the namespace files that we mentioned, and you'll see an R folder. Okay, and that R folder currently has nothing in it, but it's made the folder for you. Okay. I think quite a few people are getting
Yeah.
errors in the chat. Yeah.
Yep. I'm working with IT on that one. So
Okay.
I think it
Um,
should be good for the people that were
are
able.
already in.
Yeah, but I'll
Okay.
let me see if I can work with them on the back end for that.
Okay. Um, so if you are having uh issues, bear with. Okay. And you can ask questions in the chat if you want to catch up at a later point. Okay. But the only sort of thing we've run here is use this create package. We've given our package a name. I've chosen cookbook, and it essentially opens up a new R project for you. Okay. So we've made an R package. Okay. We've made the whole thing. Okay. So we've installed um, So we've generated our R package, and we've talked a little bit about these two files already, the description and the namespace. Okay. So what I want to do is have a little look at these files. Okay. So the description file is our metadata. Okay. So it's pre-filled with some information for you. Okay. You're going to want to update some of that. Okay. So package is the name of the package. Gets filled in with whatever you named the package when we created it. Okay. Title is is confusingly actually more of a short description. So I'm just gonna say this is a cookbook of useful functions. Okay. Version number, again, I would leave that initially. You can fill in your author details. Okay, so it's got placeholders for your name. You can put in a description, a longer description of what the package does. And there's another one here called license. Okay. And that is basically a little bit of an instruction if you're sharing your package publicly, that tells other people how they can use your code. Okay. So you can choose different licenses. Okay. I'm not going to go into licensing for code here, but some of the most common ones are sort of Creative Commons licenses or MIT license. Okay. Um, and you can see there's a little suggestion here of how do you add um, uh, a particular license file. Okay, so again, we can turn to the use this package, okay, that does those exact sort of things for us. Okay, so we do use this double colon and then use MIT license. Okay, and I'm just going to save the edits I've made. We do use MIT license, okay, and you can see that it's done a little bit of updating. It's made a license file. Okay, so this is just sort of a license that explains who the copyright holders are. Okay, and it's set license to MIT license in the description. Okay, so it's done quite a few things for us there. It doesn't touch the rest of your code in or your description. It only edits this license file. Okay. And then what we can do is we can install the package. Okay. So what you'll notice at in the top right here where you have the environment is that you have a tab here called build. Okay. That tab kind of only appears when you're in an R package project. Okay. And you'll see that it's got some different options here. Okay. You can install, test, check, or more, and we'll come to those later. All we're going to do now is click install. Okay. And you can see that it prints out loads of stuff in the same way that install.packages installs prints a bunch of stuff. Um, uh, okay. Um, I'm assuming this is related to Phil fixing things in the background,
That is
maybe?
happening.
Yeah.
Yeah,
Yeah. Um, let's see if we can resume session.
yeah, let's see if this kicks off.
I'm hoping that that was not a response to me installing an R package and was just going on in the background.
No, I
Right.
don't.
Okay. Yeah. Seems to have worked. Well, okay. So you click install, and that's very similar to running install.packages um in R. Normally you get all this sort of output, okay, but the bit you're really looking for is this done cookbook. And what it does is it restarts your R session, okay, um, and runs library for you, okay. So you have made an R package, you've installed it, and you've loaded it, okay. So we've essentially really only needed one function and to click one button. Okay, use this create package. Um, it pre-populates it with a bunch of default stuff. Click install. You've made an R package. Okay. So what I'm going to get you to do is do all of that. Okay. Um, so basically, if you haven't been coding all at the same time, now is your chance to go ahead and create that package. Call it anything you want. You can use the same one as me if you want to. Edit the description file. Okay, with a bit of a description. Um, choose a license to use. Okay, use the MIT license unless you have a different preference, and then install the package. Okay, if you've done that, have a look at the install function from DevTools. Okay, and sort of tell me what that does. Okay, and I'll have a little look at um, some questions in the chat. Okay, uh, posit link. We'll get that now. Okay, so I've reposted the link to Posit Workbench. Okay, so there is another question in the chat about why does create package not work on your computer, but it does work on Posit Clouds. It might be that you don't have the use this package installed. Okay, so what you'll notice in um, Posit Workbench is if you go to packages, okay, there's a lot of things come pre-installed um, for you that aren't normally pre-installed in most R sessions. So you might need to do install.packages, use this if create package isn't working on uh, your own laptop. Yeah, and same thing for DevTools as well. Correct. A couple of other questions in chat. So one is, does DevTools install do the same thing as clicking the install button? And the answer is yes, it does. Okay, it does the exact same thing. Okay? And you might think that having to type out DevTools :install is more time consuming than moving your mouse and clicking a button, and I would agree. But one of the things you can do is use keyboard shortcuts. Okay, so when you do a keyboard shortcut, it will run DevTools install for you. Okay, so you can do that. So if you go tools, and then you can modify keyboard shortcuts and add your own keyboard shortcut for DevTools install um, if you don't want to be clicking buttons all the time. Other question in chat is yes, and someone else has answered that's correct. Yes, the slides are made with Corto, the Reveal.js slides. So yeah, there's the question in the chat. It's a good question. Do you actually need a keyboard shortcut for this? How many times are you actually going to be pressing that install button or running install? Um, you don't you. I'm going to show you something else for sort of loading packages in a second. You're not going to be having to run it all the time, but sort of when you install your package, it installs it, with the functions, the description as it currently looks. If I edit this description or if I add a function, the the installed version doesn't update. Okay, it's not, if you were working with JavaScript, you're not getting the updated output. Okay. Um, so if something in our package changes and we want the installed version to also change, we need to go and install it again. Okay. Another question in chat, another good question. So in this authors, we have this thing called role, right? And that's basically what, for that person that you've listed, what is their role in building the package. Okay, so this one, AUT is author. Okay, so they're an author of the package. CRE is creator. Okay, so you get those sort of pre-filled by default because you created the package and you're kind of authoring it. There's other options, so things like maintainer. Okay, so someone is looking after the package but didn't build it themselves. Or things like copyright holder. So if you can put in organizations as well as people. So you can put in who owns the copyright to the package as well in here. I guess we're in a little bit of a tricky situation if I ask who's ready to move on to the next section. If you've been able to get in to Workbench, I'm going to assume you're ready to move on. Post in the chat if you're not. Perfect. Okay. If you're still struggling to get into Workbench, we can do a little recap later, or we can um, ask questions if you get stuck when you're trying to catch up. Okay. Right. So we've made a package, okay, and we've installed it and we've run library, so we know it can be installed. It is currently just an empty package. It's got absolutely nothing in it, so it's of limited use. So what we want to do is we want to add some functions. Okay. So you don't have to have made a function before. Okay, so I'm going to do a very quick recap of what a function is. Okay, so basically a function is something that has a name. Okay, so I've got an example on the right here called generate hex, okay, which is a function that generates a random hex code. Okay, so it's got a name. Name is generate underscore hex. Okay, we've defined it that it is a function. Inside these round brackets, we have some arguments. Okay, you don't have to have an argument for every function. It can have multiple arguments. Here I've just got one. Okay, and it does have a default value. Okay, so the default format is hex. And then I have some code. Okay, this is just ordinary R code that takes those inputs, does something to them, and returns some sort of output. Okay, so you can see you have return here. Okay, not all functions have to return things. Okay, if you don't put this return statement, what it does is it by default returns the last object that was created. Okay, so it would still, even if you didn't have line 11, okay, it would still return output. Okay? I really like explicit return statements, so you will see these in the functions that I write. Some people don't like these explicit return functions. Okay, choose your own style of writing functions. So how do we get this function that we've written? Okay, and how do we get it into a package? Okay, so we add functions to an R script. Okay, and it's usually called the same or a kind of similar name as the function. Okay, it doesn't have to be. You can call it anything you like, but for your own sanity and everyone else's, try and call it something similar enough that you can figure out where different functions live. Okay? And we add that R file to the R folder. Okay, so you can see when we created that package, we got a folder here just called R. That's where we're going to put all of those scripts with our different functions. Okay. One of the things that is a little bit annoying about R is that we can't use subfolders to organize our functions. Okay, so if you got a package with lots and lots of functions in it, you might want to be sort of grouping them together in some way rather than just having lots and lots of files. Subfolders aren't an option, but what you can do is put multiple functions in one script. Okay, so if you've got two functions that are like really similar, you can put them into one script. Okay, we're not going to sort of dive into that today. We're going to be making a really simple R package with just one or two functions, but there are some ways to organize your code. Okay, so what we're going to do now is we're going to add, I'm going to do a live demo of adding a function to a package. Okay, so I'm not going to type this out. I'm just going to copy the code over. Okay. So I want to make a new R file. Okay, so new file R script. Okay, paste that function in there and save it. Okay, and you'll notice that again, RStudio is quite kind of clever that it knows that you're trying to save an R script. So it puts it in that R folder by default. Okay, and I'm going to call it generate hex. Okay, so I've made an R script and it's in there. Okay, so what I'm going to do now is I'm going to install the package again. Okay, so again, it's done. It's done library, and it said it's restarting my R session. Okay, and it's run library cookbook. Okay, so all going well. If I do generate X, okay, which is a function that exists in the cookbook package that we've loaded, okay, it says it can't find the function. Okay, why not? Okay, so there's a couple of reasons why it can't sort of find that function. The install button or the install function from DevTools installs your package into R like any other installed package, okay? In the same way that you do install.packages, okay? And it's really useful for installing packages that you're kind of ready to use or ready to, test a bit more broadly. There's another function in DevTools, okay, called load all, okay? And it sort of simulates installation and it loads everything, all of the functions, all the data and the code that you have. Okay? And it's much more useful when you're developing a package. Okay? Did you notice that when you click on install, it takes a little while, okay, to actually install it. Okay? If you run DevTools load all, okay, that's much quicker than installing packages. Okay, and now if we do generate hex, you can see already that it's sort of pre-populated as soon as I started typing. Okay, but that returns our hex code. Our function now works. Okay, so kind of related to the question that came in the chat a little bit earlier is how often are you going to be clicking that install button? The answer is probably not that often, but that load all, you probably want to be doing that reasonably often when you're developing things. Okay? If again, same trick as with install is you can add a keyboard shortcut. Okay. So I think for my keyboard shortcut, I always use I think Control Shift L. I think my hands just sort of go to that position on the keyboards. If you do prefer to sort of click buttons, if you go to Control Shift L, It's a default keyboard shortcut. You can click on load all. Okay? So that's what we're going to be using when we want to, load our functions while we're developing an R package. Okay? So there's a question in the chat, is that would install also work, but just slower? Sort of, but also sort of not. Okay, so you can see the examples here. I clicked install and then did library cookbook, generate hex. That's after it's been installed and it doesn't work. When you do DevTools load all, it does work. Okay, which is a little bit weird. Okay, but there is a reason that it's doing that slightly weird thing. Okay, and I will explain that once you've added a function. Okay, so again, if you head back into your R package in RStudio Pro, okay, add a function to your R package. If you have your own function that you want to work with, by all means, go ahead and use that. If you don't have your own function to hand, there's one here, okay, a very simple function that just says hello. You can borrow that. So add that to your R package, and then run devtools load all. Okay. And then check that your function works. Okay.
Nicola, I don't know if there were anything that you had to do in the first practice round. For a good number of people, they might be trying to repeat the exercise one to
Yeah,
catch up. That may not be a bad idea to show them that in case they have to do that to go into two. I'm not sure. So
yeah. So when you're in Posit Workbench, you want to be opening it up an RStudio Pro session. Okay. And the first thing we want to be doing is, so for exercise one, okay, the only one that's absolutely essential at this point is to use this create package and then the name um of whatever you want to call the package. Okay, you can use cookbook there if you want to. Okay, so what I'll do is I'll copy that into the chat, just in the interest of time. Okay, and when you run that, use this create package, what should happen is it will build a package and open up a new instance of RStudio in a project. Okay. You might need to click a little button that says sort of open session or open project when it tries to open a new one. Okay, and you can check which project you're in from the top right here. Okay, and this is also if you want to access a different project, you can click on it to get into it. Okay. So I'll leave that there. Do you post any questions you're having in the chat?
yeah.
We can have a little look at exercise 2 again. Okay, so what we want to do for exercise 2 is we want to add a function to our R package. Okay, so if you don't have your own function, feel free to borrow this one here. Okay, there's a little button in the top right of that code block. You can click that and it will copy this function for you. You want to add that to a new script in the R package you've just built, okay, and then run devtools load all and check that your function works. Do you just post in the chat if you've got any questions, and tell me sort of when you're generally ready to move on. There's a good question in the chat. Is there a way to check if load all has worked? Or do you only know if it's worked, if you run a function? When you run load all, you'll get, this little bit of text that says it's loading cookbook. If there's any reason that it doesn't work, you'll get an error message here. But yeah, it's running load all doesn't guarantee that your functions work. But um, it, if you if you get an error message, it's a sign that it hasn't worked. Unfortunately, the error messages are not always helpful. But yeah, testing functions is generally the way to check that it has worked. Oh, oh, you've got an error with load all. Yeah, that's fine. Um, um, so there's a few people getting warning messages. What I would say is that warning messages are warnings, they're not errors. Okay. Um, we'll get rid of that warning message in a second. Um, basically what it's saying is that there's no um that the namespace is kind of not there yet, and that's fine because we're going to deal with namespacing in a second. Um, one question is what's the best way to identify the issue that the function is not found? Um, so I think with that, first of all, check that you've spelt the function correctly. Typos are a bigger source of errors and pain than we'd all like to think. Um, but what that generally means is that the function doesn't exist anywhere in your R environment or any packages that have been loaded. Okay, so check that the package has been loaded. Okay, and check the spelling of it. Okay, I'm gonna in a second in the next section um explain how we make sure that we can find our own functions when we install packages. Okay. Okay. So if you're doing um, install, okay, DevTools install, I would expect you to get an error that says couldn't find it. If you do DevTools load all, I would expect your function to work at this point. Okay. One more question in the chat that I'll answer at this point, which is what happens when you use the same name of the file as a function name. Um, nothing happens. Okay, that's perfectly fine to use um, the same file name and function name. Okay, you might be asking that question because you notice mine are slightly different. So in the file name I have a dash, in the function name I have an underscore. Um, that's purely personal preference. Okay. I like file names with dashes in them. Okay. If R would let me have dashes in it, I would, but that's not a sort of valid name for an R function in the same way it's not um, a valid name for an R object because it thinks this is a minus sign. Okay, so I tend to replace them with underscores. Okay, and yeah, you kind of in the chat, Renato, yeah, R doesn't really care about the name of the file. It cares about the name of the functions. Um, naming the file something similar is helpful to humans rather than helpful to R. Okay. Okay. Are we feeling ready to jump on to the next section? Yeah. Okay. So we want to write some documentation, right? So we can use our function, okay? So an example there of running that function and getting an output, so it works, okay? But as you saw when we did install the package, it didn't work, okay? So that means that if I gave my package to someone else and they tried to install it, they wouldn't be able to find the function. So what we need to do is we need to export our function. Okay? We need to tell R, this is a function that I want other people to be able to use, okay, when they install the package. Okay? In R, you can have exported functions and non-exported functions. Okay, so if you've got some nice little helper functions that a user's never actually going to need, you don't need to export them. They won't be able to find them as easily. Okay? But if we export our function, that basically makes it available to um, to any user who's installed the package. Right? And the easiest way to do that is using Roxygen 2. Right? So Roxygen helps us write a namespace file. Okay, so if you remember from earlier, our namespace file is a combination of a shopping list and a bit of a menu. So we're going to write down anything we import. Okay, so if we want to use functions from other packages, okay, we can do that, but we need to say, go and get this package, okay, this function from that package. And our namespace also has our list of exports, so that menu of what's available to people who use the package. Okay. Easiest way to do that is using Roxygen 2. Okay. So let's head back to our studio. Okay. So in Roxygen, okay, we write our Roxygen tags or comments above the function. And Roxygen tags always start with a hashtag and then an apostrophe, right? And that's just how Roxygen tags always begin. And if I type at, okay, I want to do at export. Okay, so what you want to do is export this function, okay, so it's available beyond um, the package. Um, so available to people outside of the package, okay, not just to other functions. Okay. So that's how we run export. Okay. What we want to do is we want to make sure that in this namespace file, okay, you can see that it's currently, other than a message that says don't edit it by hand, it's currently empty. Okay. So we want to use the DevTools document. Okay, so if I go DevTools document, okay, what this is basically saying is take this Roxygen tag, process it, and update the namespace for me. Okay, so if I run this, okay, you can see that it says it's updating the documentation, it's writing the namespace. So now if I open up the namespace, okay, you can see that it's been edited. Okay, it says export generate hacks. So it's saying one of the things I'm exporting from this package is this thing called generate hacks. Okay, so now if you install your package, okay, and it's going to say done. Okay, it's going to say library cookbook, and then if I go generate hacks, okay, I get that warning message. Ignore it for now, but you can see that my function is now found. Okay, so anybody who installs that package has access to any of the exported functions, and we've exported it so they have access to this one. Roxygen is also helpful in another way. So Roxygen, again, great. It saves you having to do a lot of stuff by hand. Okay, so this might seem like a slight divergence. Okay, um, what happens when you look at help files? Okay, so I really like ggplot2 package, so I'm going to look at the help files for that. Okay, so if you do question mark package colon geonpoint. Okay, what that does is it brings up the help functions, help files for the geonpoint function from ggplot2. Okay, and it's got this nice long description. It's got here's the usage. It tells you what the arguments are, what to expect. Gives you lots of information. And if you scroll down to the bottom, it's got a whole bunch of examples that we know actually work. Right? So this is really nice, right? If you're using a function that's not very familiar to you, it tells you how it's working. Okay. So how do we write these help files? Okay. All that stuff comes from something called a man folder. Okay. So you don't get one created by default. Okay. So again, if we look at the ggplot2 version, okay, here's essentially what the source code for those descriptions look like. Okay. And quite frankly, I think that looks horrendous. Right? You've got like lots of LaTeX formatting. You have to highlight all the code. You have to put links in brackets. That's not a fun experience for anyone to have to write this out by hand. Okay. And again, in the olden days of our package development, you did have to write these out by hand. Okay. But With Roxygen, we can put our sort of examples in our documentation with our functions. Okay, so if you look at the source code for GeoPoint, okay, again, it is still quite big, but you've kind of got this description and the examples. Okay, it looks very similar to our code that's just been commented out. Okay, and that's essentially what it is. It's just our code with some Roxygen comments. Okay. So there's lots of different options for writing Roxygen tags. You can go really, really complicated like ggplot2 if you want to. Okay. But the most common ones that are kind of essentials, okay, we've already seen export. Okay, you tell Roxygen that you want to export this function and make it available. Okay. There's also one called param. Okay, so that's if you've got arguments to your function, what does that argument do? If is there any default values for it? Okay. Returns is another one that's really, really useful. Okay. Um, so if if you've ever used a function and its output just looks really messy and you're kind of not sure, is this like a data frame, is it a table, is it a list? Like what is this? Returns will explain what type of object it is that you should expect to get out. And we can also do examples to show how does a function work. So we're going to do that for our package here. Right? So again, it's all going to be sitting inside Roxygen comments. So the first thing I'm going to do is add a Roxygen comment without any sort of argument. I'm just going to give a little description of what the package is or what it does. Okay? And you don't have to constantly type out hashtag and an apostrophe. As soon as you write one Roxygen comment, when you hit enter, the next line sort of gets prefixed with that anyway. So we want to do param, okay? And as soon as you start typing it again, it suggests those Roxygen tags. And if you tab along, it tells you how many different things it expects. Okay, so for parameter, the first thing we need to put in is a name. Okay, so we have our argument, okay, called format. Okay, and so that's what format should the output color be. And we can say that the default is X. Okay, it's useful to write down what the default values are in your documentation. Okay. The other thing we want to put in here is returns. Okay. It used to be called return. Okay, you can see that it's been superseded in favor of returns. So pick the second one. First one still works. Okay, what our function returns is a character string. Okay, so you don't need to go into lots of detail if if it's a simple output format, but it might be something you explain in a bit more detail if the output format might change depending on the input or something. Okay. And then the other thing we wanted to do was some examples. Okay, and what we do here is we just type out our code, okay, underneath where we write examples, okay, and it's still going to be prefixed with that Roxygen comment, okay, but it's just here's an example of some code. It can be multiple lines if you want to, but it doesn't have to be. Okay. So then what we're going to do again is rerun that documentation step. Okay, so DevTools document. Okay, and you can see it said it's been writing generate hex.rd. Okay? And if you go into your files, you'll see there's a nice new folder called man, right? And inside there it has generate hex, and it has written out it's taking your Roxygen comments that are reasonably nice to write and put them into this much less nice to write format for you. Okay. And we can check that it works. Okay. So if we do load all, okay, again, and then if we do question mark generate hex, Okay, so the same way we looked for the help functions in ggplot2, okay, if we do that, we get our nice little bit of documentation here, okay? And we can run our examples if we want to. Okay? So it's your turn again. Okay. So what I want you to do is use Roxygen2 to export your function. Okay. Add some Roxygen tags to document your function. What I would say is that I think for me, documenting functions like this is probably one of the things that I do use LLMs for quite a lot. It's generally okay at, I don't know, doing the boring bit of documenting your functions. Then update the documentations with DevTools document and go and read your own help files. Okay, so have a go at that. One thing I did mean to mention earlier, when we're doing DevTools load all, it's loading all of the functions that exist in our package. Okay, so we want to make sure that we don't run our sort of load our function outside of the package into the environment. Okay, so you can see that our environment is empty, and that's exactly what we want. Okay, if we bring our package into our sort of global environment, when we do load all, we now sort of have two copies of the function called the same thing. Okay, so load all is always going to be loading the most recent one. But this one in the global environment is a sort of snapshot of what it looked like when it was loaded in, and it's quite easy if you've got stuff in the global environment and in the package, it's hard to know which one you're running. Okay, so we want to make sure our environment is empty. Okay, so we always load stuff with DevTools load all. Okay. Um, so with that in mind, um, go ahead and add some Roxygen tags, and I'll look through some questions. Right, a few good questions. Yeah, so there's a question about, is there a sort of hierarchy between the different Roxygen things? Does it matter what order you put these in? No, it doesn't matter what order you put them in. Um, I I don't know, this is just the way I tend to do it. I do um um tend to put export last, um and param first. It's the order things appear in the help files, which I think is just now I'm just gonna play with things. So I can do this the other way around. So let's redocument this. And then if I look at the help files, okay, it doesn't change. Okay, so the order that you put things in the order of the Roxygen tags doesn't matter. This is the order that our help files take. What I generally find helpful is putting them in the same order, because it makes it easier to, edit and keep track of things. So you don't have to, basically. Um, yeah, order doesn't matter, but again, for things that are human friendly, stick them in the same order as R spits them back out in. Okay. Um, so yeah, another question in chat, an easy one. What happens when you click run examples? Okay. Um, in here, it's not gonna work just because of this workbench environment, but what you can do is run it sort of on your own laptop. Okay. We're kind of in development, so we'll come back to that in a little bit later. Another question is, how can we add comments after Roxygen commands? Do you mean just sort of R comments, sort of normal ones? You can do that in Roxygen as well. So if you want to add just normal R comments somewhere, you can do that just as normal. Okay, you just get rid of the apostrophe and write um, whatever comments you normally would. Um, you can put comments in the examples. You might need to escape the hashtag by putting a slash in front of it, something like that. Okay, because Roxygen tags kind of interpret Markdown. Okay, so the little things like for formatting, a hashtag in Markdown is kind of a new section heading, so you might need to escape it. Okay? But usually you wouldn't need to write too many comments there. Okay. Another question is how do you add a description to a function in Markdown format but not using Roxygen? Um, so it's quite hard to mix and match between using Roxygen and not using Roxygen. Okay. Um, so if you want to add a description using Roxygen, you just sort of write it in like plain text without any arguments. If you didn't want to use Roxygen, what you'd have to do is go into files, you would have to make this file, so the generate hex.rd, okay, you'd have to make that by yourself. So you can put in your description here, okay, and write that down. There is obviously a trade-off between adding a dependency on Roxygen versus having to write stuff out by hand. I always opt for the add the Roxygen dependency because I don't want to write that out by hand myself. So yeah, there's another good question in chat. Is do we do the same if you write a function that makes a plot? Yes. Okay, so Roxygen, it basically doesn't really matter what your function does. Okay, it always follows this same format. Okay? Um, you can, if you're doing examples, what you can do is say that those examples shouldn't sort of run um, when you're sort of generating the help files if they're really big or if they make really big plots or anything. Right? But yeah, Roxygen doesn't really matter what your function does. It just wants to know what do the different bits mean. Okay, are we ready to move on to the next part here? Okay, so we have an R package. It's got a function. We've checked that we can install that function, install the package and use the function. It's got some nice documentation. So are we ready to share that with someone else? Okay. We can install it and it works for us, but how do we know that it's going to work for someone else when we give it to them? Okay. We should probably run some tests first. Okay. There are different types and different sort of levels of testing in R. And I mean, essentially our package works, and if we're the only ones using it, then there's an argument you don't need to run any sort of tests. But what I would say is if you are sending it to someone else, at the very least, try and run something called RCMD check. Okay. It basically checks the sort of basic things of like, do the functions run? Do they all have documentation? Did you leave something behind? Okay, have you accidentally left an R script hanging about somewhere or like an old markdown file that shouldn't be there? We can do things called linting checks. Okay. That basically checks, is your code well formatted? Okay, does it match the style that your team works with? We can do unit tests. Okay, so we can check each function works as you would expect it to. If you are expecting an error when someone puts in an argument that's, not the right type or completely wrong, do you actually get an error? And then there's also some additional checks that you can run if you want to submit your package to CRAN. Okay? And that basically checks, does it work across different operating systems? does it work with the most recent version of other packages that you're using? And I guess, and sometimes most importantly, does it not break any other packages, right? So it depends, you know, who you're sharing your package with, how far you go with these levels of tests, right? So all we're going to look at today is RCMD check. Okay, and I'll run RCMD check on our package in a second. Um, Sometimes I think the output from RCMD check looks like a little bit scary and a little bit intimidating, okay? Because you get this big like message of big red text of like, oh, you have all these errors, all these warnings. Okay? It doesn't mean that your package doesn't work. Okay, sometimes it's just like it's a little formatting thing, but ours like it's a big error. Okay, if you ignore the errors, it doesn't mean again that your package doesn't work, but it means that other people might find it harder to use. Okay? Um, I added this bullet point in earlier when I was testing stuff. Is sometimes RCMD check gets a little bit stuck, like halfway through, and you get like really weird error messages. Um, Good starting point for that is like switch it on and off, and then rerun RCMD check, and hopefully it runs without any errors in the check itself. Okay? So yeah, it's it's scarier than it looks scarier than it actually is. Okay, so let's look at how do we run RCMD check. Okay, so again, we can use either the functions from DevTools or the buttons. Okay, so what you'll see here, if you go again to that build tab, um, and we click check, okay, you can see it does a whole bunch of stuff and spits out loads of information and tells you what it's doing. Okay, so it's doing things like checking that each function um, is um, sort of runs essentially. It's running those examples. Okay, um, it's checking that there's documentation for everything. That if you're using packages functions from packages externally, that you've told it about those. Okay, and so it gives you all of this stuff. And generally, you're not looking at all of this stuff until you get to the bottom and you see whether are there any errors, are there any warnings, are there any notes. Okay, so generally you want to try and fix the errors. Ideally, um, you'd also fix the warnings, the notes. Sometimes you just can't get rid of them. Okay, so let's have a little look at our warnings first. So these messages are usually quite helpful, okay? Once you get used to kind of the language of them. Okay, so what it's doing here is it's checking the dependencies in the R code, okay? And what it said is there's an import not declared from string R. Okay, so in this generate hex function that I'm using, okay, I have this string R here. And what it's basically saying is, okay, you've used that function from string R, but you haven't told the R package that you're using it. Okay, so if you look in the namespace, there's nothing in there that says one of the imports we need is string R. Okay, one of the things we need to add to the shopping list is that string R package. Okay, so we can do that. Okay, we can fix that error. So we can use this package. If we do use package, okay, and we type in string R. Okay. So what you can see that that's done here is it's edited that description file. So it now has this thing called imports. It says we're importing string R. If we then do DevTools document, okay, we're going to update that namespace. We go back to our, it has not updated that. Okay. The reason, okay, let me look at this note here. Okay, so the note that's here is sort of similar to the warning. Okay, so what it's saying here is you've used this call to RGB function, okay, this one here, but you haven't defined that anywhere, right? So you haven't added it to the imports. It doesn't exist in the package. Where's it from? Okay. And it gives you a little hint. It says you should probably add this to your namespace file. So what you can do is you can follow this advice, or you can use namespacing within your function. Okay, so if I do gr devices : okay, that's basically saying, okay, use this call to RGB function from gr devices. Okay? And if I do use this, use package, okay, I can do that again, okay, and it's going to add that to the imports. So if I redocument and run rcmd check again, it does take a little while sometimes. Okay, you can see that that error and that warning has disappeared. Okay, so the error was because we wanted to use things from string R, but we didn't have it in our description file. Okay, the warning was because we hadn't said where this function was from. Okay, using namespacing isn't the only way to add a dependency on something else. You can also do it with Roxygen tags. Okay, so what you can do is you can do at import, you can import an entire package. I would recommend never doing that unless you have a really, really good reason. Okay, because that will import every single function from that package, and it's a really good way to cause lots of conflicts. What you want to do instead is run at import from, okay, package, and then the function. So the package is gr devices, and the function is call to RGB. Okay, so adding this line is the same, it has the same effect as using namespacing. Okay, I'm a big fan of namespacing, so that's what you'll always see in my code. Okay, but both of them work. All right, so all I wanted to that's all I wanted to say there. Okay, so what I'd like you to do is edit the function that you used earlier, that you added to the package, to make sure it uses a function from somewhere else. Okay, you can use this edited version here. Okay, so this is this string to title function, again from the string R package. Okay, to make sure name is capitalized. So you can borrow that function, then run rcmd check, and then try to fix any errors or any warnings that you get. Okay, this is like a really common note about being unable to verify the current time. It's one of the notes that you can ignore. Okay, yeah, you get used to which ones are important and which ones aren't. Okay, you can ignore that. It's basically just saying that the system that it uses to check what time it is, it can't connect to it, and that's fine. Okay, so don't worry about notes too much. Try to fix errors, warnings ideally, but don't worry about notes very much. Okay, so again, post questions you've got in the chat. Have a go at dealing with some function imports and things. There's a few questions in chat. So one is, does Roxygen kind of support multi-language? Not really. But I mean, it depends what you mean by multiple languages. So Roxygen is an R package, so it is designed for, documenting R functions. You can, you could have some Python code sitting inside an R package, but the wrappings around that generally Like it'd still be attached to an R function. Um, so other languages have similar like functionality for writing nice comments to make documentation. Um, but Roxygen is specifically an R package. Okay. Um, Another question in chat. The difference between paste and paste zero. Um, Paste adds a space in between everything. Paste zero, no spaces in between things. Okay, a few, I guess, more philosophical questions in the chat. Um, but naming things is hard. So how do you name things? Um, and it's sort of related to the next question that came up on OOP and S3. So on naming things, I tend to go with um like verbs. Um, I guess that's probably slightly inspired by tidyverse in that names are quite short and quite descriptive and explain what the function does. Um, the S3 and OOP thing is okay. So sometimes when you call the plot function, it will give you different types of plots depending on what what argument you put in. Okay, so if you just call plot on a vector, it makes like a scatter plot. If you call it on like a linear model, you get a bunch of residuals plots. How is that working when it's just called plot? Okay, that's something called object-oriented programming. And it what that what that actually is a bunch of functions. It would be sort of plot.lm. So that's plot is sort of the main function name, and the .lm is named after the type of object. So that's why you sometimes see that sort of naming for functions. Okay, if it's a sort of main function dot object type, it might be an S3, a sort of OOP object-oriented programming function. Um, Confusingly, it might also not be. Um, so I tend to, if I am using OOP, that's a naming structure that you kind of have to use if you're using S3 OOP. I tend not to put dots or do like function dot object unless I'm using OOP because it gets really confusing for other people. Um, yeah, so one question is um, around uh, the time taken by a function to execute. So namespacing can add a little bit of time. Okay, so if you run library at the start of your R script and then just use your functions, you're basically only loading that function once at the start. If you use namespacing, it's kind of trying to load that function every time you call the namespacing colon function. Um, it depends what you're doing, um, how much of an impact that's going to take. If you're just writing in scripts, there's a new thing in most recent version of R called use, where you can use that to get around the conflicts in names, um, which is one option to minimize conflicts but not, get an increase in the amount of time it takes. Um, with package development, I haven't noticed any difference. And I think one of the reasons I don't like using import from is that you can't you can repeat it across different functions, but as long as it exists in one of those scripts, one of the functions, then it works. So then you can have like two functions that both require a function, the same function from a package, but only one of the scripts ends up with import from. And I find that gets quite confusing if you then try to like reuse that script in another project. So I mainly do namespacing um, for my own sanity. A couple of other questions in the chat. Use this, use package. No, so you don't have to run use this, use package every time after DevTools document. Do you mean load all? Okay, so we'd use this use package, and what that does is it says add the string R package to the description. Okay. You don't have to run load all every time after document if you don't want to. I tend to. Um, Usually I'm updating documentation. It's one of the last things I do. Okay. 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 Got yeah. Yes. Another question in the chat is our CMD check the same as check? Yes, it is. Okay, so you could run DevTools check instead. Okay, and again, another nice keyboard shortcut. Okay, if you actually hover over the button, okay, it says RCMD check, it's Control Shift and E. Okay, you can do either one that you prefer. So we have we've got a warning from RCMD check saying something about undocumented arguments. Okay. So it's telling you that there's an undocumented argument in your hello function. So I'm guessing that in your hello function, you have something in here that says name. Okay. And what that's saying is you haven't written down any documentation for that argument. So what you want to be doing is saying name and then an explanation of what that is. Okay. So that's checking that every single argument in your function has a param entry for it. All right. So new a few more questions in the chat. Yes, the recording will be shared afterwards. Not immediately. I don't think it'll be a sort of few weeks. So there's another good question in the chat about what's the difference between adding sort of imports from and adding it to the description. Okay, we need to do both. Okay, so using imports from is about which functions do you need from that package. Description, this list of imports is basically a list of all of the R packages that you need across the whole package. With imports, there's another couple of description arguments that you can also put packages in. There's depends and there's suggests. Okay, so by default, put packages into imports. You can see that that's what the use this package does. You can use depends if you need to use like at least a specific version of R. Okay. You can also use suggests if a package is not essential for your package to work, but it's a good idea if you have it. Okay. And I'll come on to some examples of why you might do that in a second. Okay. So I wanted to finish off with just some like brief pointers to some other package building tools that you might find helpful if you're going forwards with your own packages. Okay. And one of the things we talked about at the beginning was it makes it easier to share code with other people. So how would you share an R package with someone else? Okay. And I guess the most common way that we tend to install packages is through cran. Okay, so you can add your package to cran so that others can install it with install.packages. Okay, but that's not the only way to share packages. And it does it you know it's not always that you're aiming to put every package you make on cran. Some packages don't need to be shared on cran. Okay, they might just be shared within an organization, for example. So you can install packages locally. Okay, so if you take your package and you know email it to someone else or stick it on SharePoint and they get it locally on their laptop, we can use DevTools install local to get an installed version of that package. The other thing that's quite common if you want to share it a bit more publicly but not go through the hassle of getting it on CRAN is to put it on somewhere like GitHub or GitLab. And DevTools has um, exports some nice functions for installing from specific places. Okay, so you can use the install GitHub function where you put in the person's username and then the name of the repository, which is usually the name of the package, and install it that way. So that's a really nice way to share it with other people. And in terms of Git, um, that might seem a little bit intimidating if you're not that familiar with Git or GitHub. But what you can do is you can sort of develop all of your package locally, not use Git. But then if you make a GitHub account, create a repository, you can go add file, upload files. Okay, and you can basically just take that whole folder of files that we have here and just upload them all into GitHub. And then someone else can install your package from GitHub that way. Okay. But Git can help with managing, versions of packages. If you've got a version of your package that works, it's nice to have that sort of as the version on Git, and then you can go mess around and add some functions and break stuff without worrying about whether you break the entire package. Okay? So the Happy Git with our book is one I'd really recommend for getting started. And anytime I'm setting up Git on a new laptop, I still look at that because it's just really, really helpful. One of the other things that again I love about our packages is that so many of them come with a nice little package website, and basically there's a nice package called Package Down, which builds those websites for you. Okay, so an example again, ggplot2. Okay, so this is a package website. Okay, it's got like examples. It's got articles, it's got lists about what's changed between different versions. It's got some really nice examples. Okay. Um, so you can go into a lot of depth in package websites. And again, that's sort of all a lot of that's built from those Roxygen comments that we've written. Okay. If you are using GitHub, they use this package has a nice little function that will tell GitHub to automatically build and publish your website anytime you make a change to it. So you don't have to worry about like website deployment and updating things yourself too much. Another thing you can put in packages is something called vignettes. So again, that's a good example of this in ggplot2. It goes into lots and lots of detail about, line types, dotted versus dashed lines. That's probably too much information for a normal description file in a package, but you do want to include that information somewhere. Um, you might want just longer examples of sort of using multiple functions together to do a full analysis. I've even seen in some cases sort of journal papers in as vignettes. Okay. You can build them with R Markdown or Quarto. So the idea is combine function like code that uses the functions in your package with words to explain what's going on. And obviously, the most important part of building any R package is the hex sticker that goes with your package. Um, and there's an R package for that. So you can build um, hex stickers in R. So you can include things like plots in your hex sticker, and it will sort of export them into a nice little hexagon and save as a PNG file. So you can make hex stickers a little bit more easily. So I'll leave you with a few last resources. Okay, these slides are available online. I will update them after the session with the code examples that we've gone through. If you are not that familiar with functions yet, okay, you're kind of just getting started with functions and packages, the R for data science book has a nice section on functions with some examples that will take you through them. Um, there is the R packages book. Again, really helpful. Anytime I'm building an R package that does something that's a bit weird or I'm getting an error message that's unusual, I still look at that. If you are thinking about submitting your package to CRAN, that's also got a section that explains sort of exactly what's required, and the different steps you have to go through. And again, I use that all the time. It's really, really helpful. I also maintain this list of data science resources, as well, which has got some stuff on functions and packages, in R as well. Okay. So plenty of time for questions. But yeah, once you start making R packages, you just start making R packages for everything. So if you've gotten really into R packages after this, you're going to spend a lot of time playing with stuff and building packages you don't need. Okay. But we've got plenty of time for questions. I can see there's a few in the chat. All right. Okay. Few questions. So one is how to use GitHub Actions for package development. Um, Good question. So one of the things you can do with GitHub Actions is run tests automatically. Okay, so we can do things, in here we're clicking check, and that's checking can you install it on your laptop. Okay. You can do you can use GitHub Actions to run those tests automatically on different operating systems, um, which is really useful again if you're thinking about submitting to CRAN. So any tests that you can run locally, you can run them in GitHub Actions. Right? And if people are using GitHub and they're proposing changes to a package, you can make sure it doesn't break anything before it gets merged in to the sort of latest version of the package. Um, Other questions about Shiny package frameworks. Good question. So traditional R packages would, be a little bit like what we've done today. It would be some R functions. What you can do is you can build Shiny apps as an R package. And I like that framework for building R packages because it really helps with things like dependencies. So if it sets out exactly what packages you're using, and you can specify things like minimum version requirements in this imports field as well. And I think that's really, really helpful when you're doing things like Shiny apps. It also means you can do unit testing much more easily. You can do unit testing outside of packages, but I do find it easier to do that within a package framework. Um, it's one of those things that once you've built a Shiny app as an R package, you sort of have a framework for doing it. As is kind of mentioned in the chat, there are quite a few package frameworks out there for what a Shiny app could look like. So things like Golem, Rhino, there was Leprechaun as well. And I think I like them all, but for different sort of reasons and for different sizes of apps. Um, so some of them have a lot of functionality included in that base framework that you don't always need. Um, so you might want to use something a little bit simpler if you're just building a really simple Shiny app. But if you're building something really complicated, you become really grateful for the fact that someone else has gone through the pain of setting up this structure for you. So I like Shiny apps as R packages. Different frameworks depends how complicated you're building different things. Um, so one other question. Yes. Um, the my website and the slides and everything is all built with Quarto. It's easier to maintain one thing. Um, oh yeah, one question in chat which is really important. So Posit Workbench will sort of expire and the environment you've been working in will disappear at some point. I don't know if that's going to be over the next few days, but if there is anything that you've written today that you really want to keep, make sure you download anything you want to keep. Easiest way to do that. Okay, so if you're in the Files tab, click the little checkbox at the top to highlight everything you want to keep. Go to more, and then go to export. Okay, and that will export a zip file of everything you've made today. Okay, so if there's anything you want to um, keep it.
I also provided a link to a past package development workshop in Posit Cloud. So you're welcome to go there and explore and use that environment. But the servers will likely go down at some point in the near future just because we spin these up in the cloud. So if you were looking for more of a persistent experience, I would encourage you to check out the Posit Cloud link that I just put in the chat box.
Yeah. Okay. Good time for another few questions. So one question is there a package to import file from a Word document and generate an RTF file? I have no idea. If anyone else, it's not something I've ever done. So if anyone else can help answer that, please do. Oh, another question. Is unit testing a minimum requirement of a package, or is passing RCMD check without errors the minimum? I mean, I mean, it depends how careful you want to be, I guess. There are plenty of packages on CRAN that don't have any unit tests. It's not a requirement to have unit tests to put something on CRAN. If you do add unit tests and any of them fail during the CRAN checks, it will get rejected from CRAN and you would have to resubmit it. So if there are unit tests, like CRAN does check them, but it doesn't check that there are unit tests in the first place. So, and then if you want to be very careful and you want to make sure that everything works, then yes, you definitely should have unit tests. But it's not, it's not essential to have a package that works. So you probably should have unit tests, but a lot of things don't. I will stick around for a few minutes if there are any more questions. But otherwise, thank you very much for coming along. Make sure you download anything you want to keep. Okay. And these slides will stay online. And I'll update code when I can. All right. So thank you very much.
I just want to say a huge thank you to Nicola for such a great workshop. Really appreciate it. Really appreciate time. Our packages, the way to go.
Yeah.
So, thank you so much. Huge round of applause. Thanks for everyone for your attention. Great questions. Yeah, I think Phil put in the chat the link to get a badge or a certificate of participation for this. And for those coming to the Iron Pharma conference presentations that start Wednesday, Thursday, we've got it free because Nicola's going to be doing the opening remarks on Thursday, so get to hear her once again. So once again, really appreciate it. Gonna close the bridge now, and we've got a couple more workshops this afternoon for anyone sticking around. And once again, really appreciate everything.